allow me to introduce Sushakra, who is the Chief Scientific Officer at Wordy Labs, where he leads the Security, Privacy Research and Education team. He brings over 10 years of experience in the security and privacy industry, having worked with large enterprise clients and governmental organizations, where he has a special focus on software analysis tools. He holds a PhD in computer engineering from the Polytechnique Montréal, where he worked on hardware-assisted tracing for operating systems analysis. He invented the first hardware trace-based virtual machine analysis technique using specialized instructions and Intel chipsets. He has delivered talks, training, and lectures on software analysis and cybersecurity at major venues such as RSA, Black Hat, Carnegie Mellon, Usenix, and other forums. He is a regular contributor to the IEEE, serving as a reviewer for leading research journals and conferences. Sushakra has many slides today to cover, so he's requested that we leave the questions to the end, which time we'll entertain some questions. So Sushakra, I hand it over to you. Thank you.
Hey, thanks. Yeah, I'm going to share my screen now, and I hope all of you can see it. So hi, everyone. I'm Suchakra, and you have just read my introduction, so I think I'll just skip that. I'm part of this organization called Wordy Labs. We do code auditing, white box testing, etc. We have done a lot of open source work, and we invented a technology called as code property graph. I will touch on it a little bit. And we have found bugs in many tools and software such as Cisco, Windows, Linux, etc. And over a period of time. So it's quite packed, the agenda. So I'll just quickly run through it. We are going to cover modern trends in information security, how everything evolved, securing software and hardware, with a few examples, and then some common pitfalls and things that you could learn, especially as you work with research software and hardware. We'll have only one slide on AI and cybersecurity and see if that's useful for us, and then an open forum for discussion. So I think I just want to have preface by saying that your research projects will one day run in production environments. And I used to not think about this when I was a researcher myself. And thanks to Polytechnique Montreal for giving me an opportunity to actually develop research software, which can actually run in production. And when I grew up, I realized that actually a lot of the stuff, it can be very much lower inside the layers, but it eventually ends up running in productions. And whatever you do there in the software and hardware that you develop as part of your research, that is going to be impacted when people start using it. So we have to make them secure. Let's go to the modern trends in information security. It will also act as kind of like a historical basis of how these things have been evolving. So in 1960s and 80s, you could do things like phreaking, where if you use a cereal box whistle, which used to come in Captain Crunch, and just loudly blow it on a telephone, you can actually get free calls. And believe it or not, Steve Jobs and Steve Wozniak actually designed this, and they tried to sell it. So from there, we have reached in 2025 now, where over in 2014, 900 security cameras around the world were suddenly starting to send massive HTTP packets. They were causing DDoS. And now in 2025, 86,000 IP cameras were taken over by a bot. So, the industry is under pressure, and there is a lot of attacks that can happen from all sorts of places, nefarious use cases, and it's affecting hardware as well as software. So we need to be a bit careful. We'll take one example of network security to see how this has evolved. So for example, in the early days, you could just simply do packet filtering, allow or deny packets, and things were very much contained in one piece of hardware, and you could just control the flow of network packets this way. But as things became more complex, we had stateful firewalls, and then as things became much more complex, we could actually start doing filtering on the application itself. intrusion detection system and intrusion prevention systems were needed at that time. And then suddenly encryption hit. So you could actually encrypt the traffic, and now people felt they're more secure. But even then, you needed to know what's happening inside. So more deep backend inspection and segmentation of the network started happening. And now we have entered an era where we don't have real hardware even running the things that we write and develop and research on. So it's something running inside the cloud. So now you need more secure gateways and the similar techniques that we had before deployed in cloud. And the situation now is such that in modern 2020s, we have zero trust networks. We do not even know that even smaller pieces of software that we develop, are they even on the same machines inside the clouds? They could be completely on something that we do not know about. So you cannot trust any network packet coming in or out. Now identity is more important. So you will start to hear words like CSPM and all that stuff inside, but we don't have to worry too much about it. We'll see why we don't have to worry. We have to stick to the core tenets. And as you develop software, develop hardware, and do research, if you just stick to these tenets, I think they're important. So the modern taxonomy is kind of like divided into this. We have application security, data security, network, endpoint, etc. So application is much more focused on securing the software development as you are doing it. Data is much more focused on data at rest, in transit, etc. And network, we have already seen defending the network boundaries. Endpoint is more about end user systems. So in early days, if you are antivirus, that was like form of an endpoint security. Cloud is in cloud infrastructure, because now we are beyond physical infrastructure handling data. And then identity, managing access and permissions of who is entering the system, who is exiting the system. Supply chain, the most important thing right now, and we all have to be extremely vigilant about how we develop our systems, what are the dependencies on it, because things have become so complex that they are much more layered. And then hardware security, if you have physical or embedded systems, what things you can leverage from them. Still, the fundamentals of all these are very much same. So in other areas of industry, we do have standards. In security also, we do have standards. But in the modern world, because the speed is just so high in development, that we are left with some new infosec jargon that has come up, like ASPM, application security posture management. And when you try to search what tools should you use for securing your systems, you will start to see vendors like this, and you do not really know what these new words mean, but we don't have to worry too much about it. I'll just take example of, one of these vendors that at least I have worked with. It's called as Aquinox. I have been with them since like early days, so I know how it works. And once you know what's under the hood, and I can speak freely about this because much of this is open source, you can actually understand that the fundamentals are still the same. So if you follow these fundamentals, you would remain secure in developing the systems that you do. So under the hood, this tool still has these things called Linux security modules, which are available in all the latest platforms. And based on that, another application called as KubeArmor open source, it's again open source application, was developed. And the features inside this, for example, providing security policies, becomes part of automated zero trust policy, and alerts and telemetry that this thing generates becomes part of container and VM forensics. So it's the same thing, which is built upon well-known fundamentals in the systems, but it's just packaged in a manner. So if we stick to the core tenets of information security, which is confidentiality, integrity, and availability, we would be good. So confidentiality is that the data between two nodes, people, services, devices always remains confidential. You can enforce it via SSL, encryption, etc. Knowing that the person you're talking to is the other person is the same. Integrity is ensuring that the data is not tampered with. Only the people who are allowed to work on it, they can do it. And availability is data which is always available. So systems are available and they are not compromised. If one is compromised, the system still works. So if we stick to this, we are secure. And any tool, any technique that we work with, we need to ensure that we just kind of stick to it. So securing software and hardware, that's kind of like the second part. So we begin by two techniques that we'll be discussing, and most of the analysis of confidential integrity availability, as well as the tools that are available in the market, they can broadly be divided into static analysis, analyze the systems very early. These are code analysis systems, software composition analysis, how software or hardware has been developed, what are the components inside it, looking at them very carefully. Container and image scanning, SBOM generation tools, source code auditing, etc. And then on the other side is dynamic analysis. As the systems are running, you try to understand what's happening in them. So scanning them dynamically, tapping traffic, which is going between the systems, wireless application firewalls. We have heard the word firewall. So essentially that's dynamic analysis. Runtime protection as systems are running, trying to understand what is happening there. API security or your malware detection systems, antivirus, etc. These are all dynamic in nature. So dynamic is mostly a reactive form of security where things have already happened, and static analysis is more proactive in nature. You start with static analysis. So static analysis is analyzing computer programs before executing them to find bugs that may manifest when we execute them. Some concepts that you should understand. And these are also important because as you develop software and software for that hardware, you should understand what are the sources, what are the important points inside my applications that I should care about, which can handle data, and where is it flowing throughout the system. So having this kind of understanding is already half of the job done. So while you develop anything, be careful about where the data is coming into the system, where it is flowing out from the system. You can think about these things that you just saw very carefully by understanding the whole application and the components of the application. So in this case, we try to understand what is this is a variable, this is a function, and this is a library that is attached to it, what's happening inside it, and then ask questions like this. Find a flow from a variable which is geolocation to a log. You could ask a question like this, and then you can have systems that ask these questions at scale. So why should we do static analysis? We try to find things very early, try to find if the code or the tools that you're developing, they are exploitable very early, because the more early you catch them, the better it is. Did we introduce a new sensitive variable? Should we even have private data inside the software? So things like these fundamental questions can be answered very well if you try to do static analysis. We'll take a little side quest. I'll run fast through it. We'll try to understand programming languages a little bit, and we'll see why we want to understand them, because they form the basis of everything that is running right now. The software running on the hardware, the software that you develop, the modern AI-based systems, everything is now languages, so we should understand how languages work. It's a very, very short side quest we'll take from this. So programming languages are something that you write, and they eventually have to go into a computer, gets converted into binary. We'll look at one specific part of it, which is intermediate representation. This is essentially how a computer understands what a language is. So graphs are something that are important in this. They help us formalize and visualize a language. We as humans also think in graphs. So for example, I drive a car to my college. Essentially, you can break this down and make it more deterministic in your brain. That's how we also think, I would say, but we have very much internalized this graph formation and going through it as we grew up, and we can do it very fast. But we can make a machine also do it. So now it can actually create these little graphs out of it. Same is with computer programs that we are writing. And we created something called as code property graphs, which is again a research project. So it's a research project that started years ago in TU Braunschweig in Germany. And that project allows us to analyze other projects. So that's so cool. So which means that your research is actually valuable right now. So this allows us to ask these questions at a very massive scale, and you can actually do this asking and analysis yourself. So for this, there is a tool called as Yarn. You can go on yarn.io. This is also an open source project. What it allows you to do is take in source code that you write. It could be hardware source code, software that you write for web applications, any kind of source code. So you could take it, convert this into a graph, and then load it inside this tool called as Yarn, and you can ask questions. So for example, list all the functions in the code which handle a web route. So immediately with this, you know that there is a point, these are all the 20 points inside the application which an attacker can actually point to, because it's a web application route. You can ask deeper questions if it's some hardware about, like, are there memory leaks that can happen in some place? So this is kind of like a very early analysis, and that's what a tool like this allows you to do. There are many other tools that are specialized in static analysis. We'll come to those as well. Yeah, and Yarn is open source. You can just download it. So how does it work? Idea is to encode these patterns, and then you scan automatically. We actually scanned VLC in 2014 using this when we developed this platform. And then we found a buffer overflow in the automatic updation of the VLC media player. And then we scanned it again in 2020, and we again found a buffer overflow in automatic updater. So what I'm trying to say is that there is no end to security bugs that might be there in systems. What you can do on your end is be aware of them, try to understand what's happening, and try to find them early on. Okay, so just running through like a quick example. I don't want to do the demo to show it to you. I was thinking I'll do a live demo, but I think it's better you can just see what's happening. It's also faster. So you can generate a CPG like this. A web application, we just coded through like a prompt in an LLM, and then try to see if there is a bug inside this. And actually there is one. So we try to find a data flow from any function called get going to like an operating system function, and we can see that what we were mentally doing in our head, trying to see what's happening to the data, we can actually see it live happening and then verify whether this is a problem or not. So you can do the same thing as well and build other solutions. There are some commercial static analysis tools also, which are quite useful. There is Veracode, Black Duck, Checkmarks, Quiet Privado. A couple of these are using the same tool, but they all use some sort of graphing technology, which takes code, converts it to a graph, and then you ask questions on the graph. So they all use something very similar in nature. I have actually given a thought to it, and here are a few things that you should look out for when you develop your own software. So if you want to do some advanced code analysis, you can use tools like Yarn and CodeQL. There are more easier tools which can do very simplistic analysis like SendGrep, SonarCube, Infer by Meta, PMD, Marina Trench, and OWASP Blend for binaries. So does basic binary analysis. They can you can write your own. There are many patterns inside the code which break security, and there are many patterns available online. You can use these tools, and suddenly you can start to find that your code is secure or not. So this is more for code analysis. But then if the code is packaged already, you can actually use tools like OWASP, DepthScan, and CDXGen. These are again open source tools. They're actually developed by a friend of mine. So you can use these tools to find bugs in your application. And find dependencies inside the application. What is my application comprised of, and are there CVEs or bugs existing inside that? For containers, there is Trivy, and then there is Claire, and then Gripe, etc. So there are many tools which are specialized for certain aspects of static analysis. Some for containers, some for code, and some for all complete code analysis. So you can use any of them. Okay, so from now, we'll move on to dynamic analysis. So we have covered static analysis, some tools that you can use, some tools that would be relevant in different scenarios. And now let's look at dynamic analysis. When an application is already running, we are not at the liberty of looking at the code of the application properly, or analyzing the binary which is inside the hardware. So now let's look at, if the application is, or the device is already running, what can you do with it? So one of the very easiest things that people do is that a web application like this newspaper, New York Times has a website. It's fetching some data about weather from some place, and it's providing login and subscription services. So all these devices in your phone, they make a lot of calls to central servers, whether it be an IP camera, then it will also be connected to the internet. You can intercept these things in between. You can simulate the behavior, intercept them, and then analyze what's happening. We can take an example of mobile applications. So again, a WASP, a very good resource to get tools and understanding from. It's an open organization. Use these tools, and for operating for mobile systems, one of the tools can be APK tool or JADX for decompilation and basic analysis. And then a very important tool that dynamic analysts use is called as Burp Suite. You can intercept the traffic between your hardware, your software, and the third-party network remote cloud service which is running, and see what is happening inside it. I actually tried it. So these are two real examples of me doing this. So in one example, there was a data leakage to external entities by this application called Calorie Counter. There was some data about user ID or nutritional strategy, etc., which could be private information if grouped together. And this was being sent to these third-party services. It even has gender information, etc., about which was just being sent directly in plain text. So if you could intercept it in some manner, people would know my preferences, etc. Another was some partial location leak, which was happening through an application called Weight Watchers. This was very interesting because it's right in my office here. Um, I logged off everything, set a complete fake location, but it somehow identified that I'm on like Rogers communication. And through that, it was able to identify that I'm actually in Toronto, and got some information about my 3 digits um, of the postal code here. So I think that's interesting. You can do dynamic analysis to understand what your application is doing, or what other applications are doing, and make sure that they remain secure. They do not violate anything related to privacy. So most security actually becomes exploitable because attackers can reach them. That's a very important thing to understand. There might be very benign things inside what you develop. You don't have to worry too much about them, even though they exist. But they become only dangerous if attackers can reach them. But how do attackers think? Um, we'll take example of web applications. I know you must be developing software, hardware in different areas, but a lot of them are using web technologies. We do not know this, how deeply it is, but they are actually using a lot of web technologies. That's why I want to focus on it. I'll actually give you a real example of hardware as well as software, both using web technologies. So modern web applications, they use APIs, cookies, live connections, microservices, and these new buzzwords out there. To provide the login or browse functionality that New York Times had, or to even keep you logged in. So you don't, every time you go to New York Times, you do not, provide your login credentials every time. So there are these techniques called as cookies, etc., that are used to maintain a session between like the remote service, which will give you some information like news, etc. There could be things called as web sockets to connect you live between the remote service all the time. So these technologies become very important in modern functioning of modern devices, web devices, etc. But they also are a very good target for attackers. And attackers actually try to think that the end client, the end thing, like a New York Times website or something with which you are communicating with the backend server, that is kind of like very important for them. So front end is like a means to communicate with the backend. attackers observe how the backend behaves by sending different things to via the front end, and they can observe traffic, modify the cookies, or take over sessions. So in this case, for example, they see like an input box, they can try to inject some various weird things in it and see how the backend is behaving. They could intercept the traffic in between, or if they are very clever, they could actually hijack a authentication cookie and act as you. So now they have your connection in it, and these things have actually happened. Um, we'll take a real world example of this exact thing happening. It's called as XSS. I'm not going to go through all security details inside the whole system in the whole security sphere, but we'll take one example of cross-site scripting, XSS. This happened in eBay in 2017. So actually, on eBay, you can create a new listing. So you would log in, you can open a new listing, and then it gives you a nice text box where you fill in the title of your listing and the details about the listing. So people would be doing it. It's very easy. There's a text box, you fill in details inside the text box. But you can be very clever and fill many other things inside the text box. So for example, this listing on like a real eBay, it looks all perfect. There is nothing wrong in it. But if you click on it, it's going to cause trouble. How does it cause trouble? Because inside the text box, you can fill in these little redirection words so that once a user clicks them, they're actually redirected to a fake login page. And this type of vulnerability is called as an XSS vulnerability. I mean, there's more depth to it, but generally that's what it is. And you as a user would think this is a nice listing. You will click on it, and then suddenly it redirects you to like a login page, which also doesn't look very malicious. It is fake, but it doesn't look too malicious because you actually click something on eBay, which is a very legit place. And then the moment you fill in your credentials, suddenly the listing is gone. It's not available. Because actually it was never available in the first place. The thing that you clicked took your cookie and your credentials, the authentication cookie we were talking about here. It just took it, put it in its purse, and it sent it to somebody else. So these kind of vulnerabilities have existed. They keep on existing, and they keep on happening again and again. Yeah, you can actually prevent them. So in this real world, that's exactly what happened. Some script was run. The script in the eBay era was being added inside this. But the script got run, and once it ran, it leaked the data. You can actually validate the input of whatever input has been put in. You can set up content security policies. Again, this is further reading, no need to really go deep into it, but you could prevent bugs like this. So there is, we are not, helpless. There is stuff that can happen. So if you're very careful in writing your software properly, thinking about what is happening, or scanning them, or using proper techniques like this to prevent this, you would be quite secure and remain secure. Another example, and this is something we did in 2022, this is also us just buying a router. So all of us are using routers at our home. So this is us buying a router, finding a UART shell in it. You just connect it to some ports inside the router, and then you see an exposed web route. And with that, trying to find more and more bugs. So we found multiple buffer overflows inside the system. And using that, we also found an application that was already running. But it's interesting that you switch on the router, but before even the authentication page comes in, there is a WebSocket authentication that is happening. So you see, this is a little device. It's a little router device running here. It's a network equipment, but it's also using web technologies that we just discussed before. So you could actually craft a payload in a very specific manner, and you could completely send it to the WebSocket and completely take over the router. Just imagine somebody coming in, connecting to the router, not even connecting, but before connecting, doing something like this and taking over the router. And through the router, they would take over something else. So here, you were just simply developing a hardware and putting a little piece of software over it. And what it turned out to be that anybody could just connect to it and take over. Investigating this much more, we found that there were hard-coded credentials left inside the router. And this is not some special networking equipment. This is off the shelf, something that we just got in a store and started working on. So what I'm trying to say is that you should not do that. You should be very careful about not leaving your hard-coded credentials inside devices, which anybody could find and use them. Another example, this is actually something on last Friday. So this little investigation I did back there in my office was completed last Friday. So it's a baby monitor camera, and I'm assuming you would be developing something like this, nice camera for a research project. And you know, there are so many AI research projects now for face tracking, hand tracking, you know, worker tracking, etc., going on. You would be using a camera for that. And inside that camera, it's very similar. It's like a baby monitor camera. It's again available off the shelf. Somebody must have bought it, used it, and then I bought it from eBay on the secondhand market. And I started investigating it and found out that inside the baby monitor camera, they were storing videos, which should not happen because the camera was supposed to just transmit the videos, but they were storing the videos inside it, and they were left many videos from 2022 inside that camera. So these videos were discovered by us, and then we found out that actually somebody else had also discovered it like 2 years ago. So actually last year, not 2 years ago. So which means that these issues keep on existing. We need to be more careful when we develop our systems. We should understand that the sensors that are recording things are taken care of. We do not violate privacy guidelines, and we are very careful that nobody can just connect to this like randomly from very user accessible test pans. You could just put something in this pin, and you know, you can take over the whole device. So I think we need to be careful that that's not how we develop tools, because they, again, I mean, much of the work that went on developing this camera is actually the software that was put on this hardware, and much of that was not developed from scratch. It was built upon layers and layers and layers of software. Part of this was also very early research software, which was probably saving data on some disk. So having these boundaries and understanding that you don't do it, so that the later on when devices are using those open source tools, those techniques that you're developing, they do not get violated. So I think that's kind of like a small lesson here. Common pitfalls that I have seen when seeing software, and I'll focus more on research software here. Um, we did get an opportunity to analyze research software, our software itself being a research software for over a decade. Um, so some pitfalls that I've seen is modern software is using a lot of little microservices here and there, and folks think that yeah, this is running inside an enclosed system. There's no problem. It's just a bunch of scripts I wrote. It's like these two little services. They will run on a little server, and we are all good. Essentially, what happens is that when you deploy these things and somebody takes over the first machine uh, where all the software is deployed, they can actually inject something in between and start intercepting it if you do not secure the communication between different components of the software. So most of the web architecture is microservices these days. You would also be using microservices, if not now, then eventually, as your research projects hits production environments. Uh, it's important to use mutual TLS, where one service and the other service, when they communicate, they know that they both are allowed to communicate, and then they communicate over an encrypted connection. It's not just that only the server needs to provide encryption when it's transmitting, when it's receiving, but it's also that the client should ensure that the identities of both these are confirmed. And you can do this by using tools like Spiffy and Spire. These are again open source frameworks and platforms. You can just drop them inside the cluster properly, issue certificates to your services, and the traffic would be secure. Now, even if the traffic is outside of the boundary, it's in different cloud environments and different devices altogether, or one in Vancouver, one in Toronto. If you have the whole service, like just imagine the software is deployed in 10 different areas, completely even geographically isolated. The individual pieces of your software would still be communicating in a very encrypted manner. So this is very important to do these days, as software is moving more towards clouds that you do not control at all. Another thing is encryption failures. So I would first of all preface this by very, very simple stuff. If you think that I have encrypted my hard drive, I'm all secure, I think that's a very misconception here. If you have data on your hard drive, your machine is powered on, the data is being used, that's not encrypted. So if somebody can access it via some other software or movement, then all this encryption over a device doesn't matter at all. So that's first point that people should understand, that encryption is important, but it's only valid if you do this properly and you keep this properly. So one example is weak encryption and not using any salt. So when you encrypt passwords and other sensitive data, which you have a software that takes in like GPS locations of all traffic as part of your research project. So I mean, that's actually a real software being researched these days in one of the universities in Canada. You need to make sure that all those values are encrypted and stored very safely. So to do that, make sure that you use proper algorithms, you use latest algorithms, and then you also encrypt not just literally just the whole database itself, but actually individual tables on it. You can use multiple levels of encryption. First, the fields are encrypted, then the DB is encrypted, and over it, your whole device is encrypted. So you need to think about these things from that angle. And also, what happens if the machine is on? Can somebody completely access that? So maybe they can access the DB, but they might not be able to access the hardware because they do not have the keys. Which brings us to the second thing. Do not hard code keys or environment variables in your systems. Make sure that they can be read from proper software, which is called as vaults. So use secure vaults to keep the keys. So this separates the concerns and the keys from the users. So if a user has user's identity allows them to access some resource, they can actually request the vault software, and the vault software has all these keys for them, and then it gives them the access to those. So I think that's a very important thing. So even the users do not know what their keys are. They cannot be hard-coded. The software requests them from a vault service and then uses them. That's actually something that I learned later on. It would have been nice if I had learned early on. Okay, and the last part is software composition analysis. Software bill of materials, hardware bill of materials. Don't copy paste libraries from random locations. Always use authorized and tested repositories when you're developing software, and make sure that you use the latest tools to scan your applications, and know that if there are any known vulnerabilities in it, you should be aware what these vulnerabilities are. It's not important that you always update them immediately, but you should know, are they actually reachable from your code? If they're not reachable, they might be benign and it's okay, and you can have a plan to upgrade them. But just having a complete understanding of what are the different components, because modern software has become much more complex than it was before. There are layers and layers of third-party libraries and other people's code that you combine together to build something. So having this knowledge of known vulnerabilities inside this whole chain of software that you have is very important. So that's why I say these days, supply chain security, which is software composition analysis, having a software bill of materials, etc., and knowing this very well is actually very critical. And I would say it's so critical in research software, because much of this complex part of research software that goes on doesn't actually get changed when you deploy this in production. A good example is our own software, our own Yarn and the code analysis tooling that we have developed. nobody comes in and checks what was done like 10 years ago in it. So we need to make sure that that is remaining secure. There are nice web UIs over it and other things that are over it, which you can secure, but it doesn't matter if you do not secure the underlying components. Okay, so the last slide now, AI and cybersecurity. You might just say, well, I developed some code and I have everything ready. Let me just shove it into an LLM and it will tell me whether this code is secure or not, or it will actually fix it for me. So there are good efforts going in that direction. There is very nice research that is coming up. It's helping us find issues much more faster. That's my observation. But we are still not completely there yet. So one of the research which actually did a proper analysis of generating secure web backends, and can LLMs actually generate them or correct them properly, it found out that it was not actually a case. It achieved like almost like 62% correctness, and a lot of the issues were still there. And they noted inside their research paper that obtaining the oracle knowledge for this prompt type is highly non-trivial. So, which means obtaining this knowledge that this is secure and this is not secure in a very, very well-defined manner, it's actually very difficult given the complexity of code which is out there. So folks are tackling this. We do get some requests from folks, and we also try to tackle this, but be aware that you should not trust code generated by LLM blindly. It has been proven with these very complex, they ran like 270 different generations of backend or something like that in the paper. And they found out much of them were like not secure, like baseline 37% were okay. Rest is quite incorrect as well as insecure. So that's kind of like the final thoughts on this. Yep, I think that winds up this presentation. I mean, questions are welcome. You have my details here. You can also contact me later.
Excellent. Shushakra, that was a great walkthrough of all things security. I particularly found the 3 examples you gave of interest, and I think for everyone, the topic of AI and security is a very relevant one. And so I'll open up the floor to questions. Maybe while people are formulating the questions, I could start by asking about what your observations are around AI security and with the prevalence of agents and using agents using API tokens and things like that. What do you see? What do you see us needing to focus on in terms of AI security?
Yeah, I think that's a very good question. So, I mean, uh, we should consider agents as anybody else inside a critical system. So it could be human or it could be a software. So agents are again very similar in nature. So, for example, if we go back to the slide of keys. So in this case, an agent can be given an identity and an access, a proper access on the system, and then they can request the keys from a vault. I mean, that's one way. So instead of hard coding every key inside whatever layer you build, that's something that could be done. I've also been exploring this new technology of MCP, Model Context Protocol, which is there, which allows the agents to actually communicate with agents and whatever AI and LLM and the systems that you're building to actually communicate with real devices and real machines far. So this is proving to be a very an area which does not have things defined very clearly. For example, there's so many MCP servers out there, none of them audited, vetted. If you start using MCP server and you just ask very high level questions, can you find me the best, weather to take a stroll on in Montreal, on a summer evening, and then it can actually pull up an agent, pull up an MCP server for weather, which is totally unvetted. which can then run requests on your behalf on some other server, which are again totally unvetted. Maybe it's just taking in your GPS locations and leaking it somewhere. We never know. So I think that's a very blind spot I feel is there. I would say keys, handling of keys with agents is an issue. The modern MCP security world, which is coming up, that's also going to be one of the issues that are out there.
Great, thank you very much for that response. And definitely MCP is a hot topic in security right now. Okay, let's open the floor to other questions. We've got a number of attendees on from the Alliance. Does anyone have a question? If so, raise a hand and we'll, or pose the question in the chat and I can make sure that we get it covered. I haven't seen any hands come up, but this is a nice slide to end on. So these are ways that people can get in touch with you and if there's further questions.